Okay, it's time for 3D, our last unit of the year, and quite ironically, just our last unit that we're studying in their final. So the first task is to identify the parallel and perpendicular cross sections of a shape. Okay, you may not be familiar with the terminology, but that's not really a big deal. What we're really talking about is how to slice up this object dimensionally. And so they want you to take it two different ways. If you're slicing like parallel to the bases, or if you're trying to cut the bases kind of like down the middle, and they want to try to identify what the shape is. The best thing to do here is just to draw them in. So the parallel one I'm not going to draw in because it should be fairly obvious because it's in the shape of the base. So like if I take this and I slice it here and I kind of peel it open, like the shape I'm going to see right here is going to be the same size as the base. It's going to be a circle. So I'm not going to focus on drawing on that one because it's fairly easy to pick out just by knowing the shape. So the parallel cross section here is a circle. Okay. Now perpendicular is going to be a little bit different because I have to think about cutting it like straight down, like let's say a ninja sword is cutting it. And so I have to kind of examine what that cut line would be. And so if I cut this in half top down, that would be my perpendicular cross section, perpendicular to the base. So if you think about what that shape looks like, I'm looking at least a rectangle. I can say rectangle confidently because that is not an oblique shape. Right? Let's try another. Now parallel cross section, not going to write it. That's going to be a triangle because again the whole shape's in a triangle. The more interesting one again is a perpendicular cross section. So what if I were to cut this again straight up and down? So I'm going to do it here. So I'm going to cut it along the back baseline, cut across. It looks like again we're looking at another rectangle. Okay. Let's go number 4. Now this parallel cross section, again, this is parallel to the base. You may be thinking, well, is this different now because it's a pyramid? It's not actually. It's still going to be in the shape of a base. It's just going to be much smaller. So what I mean is this: if you think about the dimensional build of an object, okay, it's just the same plane getting cut more and more and more as you reach the upper plane. So it's still going to be in the shape of a base. So again, it turns out to be fairly uninteresting. In this case, it looks like it's going to be a hexagon. Okay. Again, now the tough part is what does it look like if I cut it straight up and down? Well, let's start at the peak. Let's run down. Oops, there it goes again. Let's start at the peak. Let's run down this side length, cut it back to the back end, and go back up. Well, because you only have that one shape, one base, and you're trying to meet the upper plane at a point, it's going to cause this cross section to also be a triangle. So if you kind of imagine this being on a clay and you cut it down right down the middle and look at what shape it is like on the inside, you're going to be seeing a triangle there. Okay. Uh, Parallel cross section rectangle. Cut it right down like it's a block of cheese or something. And again, you're going to get another rectangle. Okay. So here we have to draw the 2D shape that would rotate around the axis to create a 3D shape below. So what we're really looking for, if this is the axis of rotation, what does the profile look like? Like what would cause you to have this configuration? And so let's say we come to a point, we come back, not quite, missed it. Go to a point, come back not quite far, drop straight down, start to go back out, come back in as a point. And so like this itself is going to be the shape that we're going to make here. So we come out, come down, don't quite hit the axis, come down, come back out not quite as far, and all the way back down. And so like the key to these rotational solids is thinking about where the axis of rotation is. Same thing here, like the axis of rotation is going to be right down the middle. So one thing to note is that this is going to be hollow, and so like you have to come out and then go down, but it's going to be hollow, so we're going to have this other thing kind of tracing it there too. And so when spun around, it's going to create an opening. Actually, I made a mistake here. Because we have this opening, that means we cannot touch the axis at the top. If we connect it to the top axis at the top, it's actually going to be enclosed and looks like it's hollow here. So to transfer it, there we go. So we see the same kind of dilemma with a donut. It's got to be open at the top, or it's got to, I'm sorry, have an opening at the that goes through the entire thing. So none of this can actually touch the axis. So for the donut, we're looking at something really just this section right here. So yeah, it's pretty close. Maybe a little sharp edge of that donut, but that'll be okay. So the thing to note here is like since this first one is completely closed up, that means it has to start and end by touching the axis. This one starts open then closed at the bottom, so it's going to start away from the axis and then touch it by the end. Whereas the donut, it's not touching any part of the axis, so none of this cross section can too. All right. So here we have to name the shape that will result if you rotate a 2D shape below around the lines given. I would personally, again, utilize drawing techniques and realize if we're drawing this kind of around, what you're creating are a bunch of discs. So as you're kind of drawing this, if you think of this in terms of like stacking discs one on top of the other, it'll give you a good sense of kind of what shape you're looking at. And so again, this is round because it's rotational, but if all these discs get stacked one on top of the other, what we actually have is going to be a cone. And it's going to look more or less like this. There's the bottom, it's going to have nice stacks at the top. If you think about your parallel cross sections, like that's where they're going to fit into your cone. Okay, well, let's do the same thing we did before. I'm going to think of in terms of like these cross sections kind of increasing. From the bottom to the top, then we kind of start to shrink back down together. You can almost see the shape form right in front of your eyes. This is going to be a sphere. So it's going to be basically just a big globe, and where you have all these cross sections kind of stacking one on top of the other. Okay. Now, the deception here is a lot of people think this might be a cube, but again, think of it in terms of like stacked round cross sectional discs, and you'll find this cannot be a cube because it's round. Instead, this is going to be a cylinder. Okay. And so if you think about the picture of a cylinder, think about those like round cross sections stacking at the very top. You can see that shape's going to match pretty darn well. All right, so there's part 9 for you guys. We have one little bit in 3D, and guys, this review is over.